Welcome to our competency-based question series designed chapter-wise to enhance your conceptual learning and understanding. Question 3. In the circuit containing two cells of EMF 30 volt and 10 volt, we have to find out of these 2 points P and Q, which one is at higher potential. So let's first find out the current flowing through the circuit using Kirchhoff's law. Using Kirchhoff's voltage law, we can find out the current flowing in the circuit, and let's take the direction of the current as this, that is from P to Q. So let's try to find it out. We are entering the negative terminal of the battery, and hence this voltage drop will be positive. So it will be 30. We are moving in the direction of the current, and the voltage drop in the resistor will be negative when we are moving in the direction of the current. So it will be minus 30I. And when we have reached this battery, we are entering from the positive terminal. So we have to take this voltage as negative, minus 10. And then this current will move through 15, 5 and 10 ohm respectively. So since we are also moving in the direction of the current, we have to take the voltage drop across each of the resistors as negative. Minus 15I, minus 5I, minus 10I, and this has to be equal to 0. Solving it out, 30 minus 30I, 15I, 5I, minus 10I, that is equal to minus 60I, minus 10 is equal to 0, and this gives us 20 is equal to 60I. We can solve this as I is equal to 2 by 6, that is equal to 1 by 3 ampere. So the current that is flowing in the circuit is 1 by 3 ampere. Now we have to find out the voltage difference between points P and Q in order to find out which one is at higher potential. So let's apply the Kirchhoff's law for these 2 points only. That is, the voltage at point P is Vp and voltage at point Q, it is Vq. So when we move from P to Q, then whatever be the potential drops that we are encountering, that must be equal to Vq. So first we have encountered Vp. So Vp, since we are entering it with the negative terminal, it must be positive. So plus 30, then I into 30. I is 1 by 3. And since we are moving in the direction of the current, it has to be negative. Minus I into 30, that has to be equal to Vq. So we got Vp plus 30 minus 1 by 3 into 30, value of I is 1 by 3, that is equal to Vq. And when we solve it out, Vp plus 30 minus 10, that is equal to Vq. This implies Vq is equal to Vp plus 20. Since the voltage drop at point Q, that is Vq, it is 20 more than Vp, we can say Q is at higher potential than P. And that's the answer for it. Thank you. Keep learning, keep practicing, keep excelling.